Now for the problem number 2 for the relative velocity equation, we have the mechanism of two links and connected to a slider. So we have the slider C that's going downward with the velocity of 4 meters per second. So it's going to go to that direction. By moving this direction, it's going to take the link BC to the movement of the clockwise direction. And this one is going to take the link AB to the clockwise direction omega. In this question, by knowing only that we have the 4 meter per second for the velocity c, we would like to know what will be the angular velocity of the bar AB here. So again, our plan is to use the problem solving procedure using the relative velocity equation. So the sequence of the solution is going to be, now we can see that we divided the link into two links. The first link is going to be the AB and it's going to be fixed at the point A. That means the velocity at the point A is going to be equal to 0. The movement of the rotation will make the rotation going in an arc. And we have the velocity that is going to be perpendicular to that link. In this instant, this velocity, which is perpendicular here, is only going to go to the y direction. Now when we're going to get the velocity b, I'm going to take it to that equation here. And in this link, again, we're going to have two velocities at both ends. So we can write down the relative velocity equation, which consists of the velocity at end 1 is going to be equal to the velocity at the end 2 plus the omega multiplied by the scalar vector of the link BC, which is going to be sketched as a triangle, and we can find its x and the y component and write down the equation. So we can find first the relation for the omega AB and the velocity B by simply taking the first link and write down the equation for it. So it's subjected to rotation about the fixed axis, and then we are going to simply write down that the velocity B is going to be equal to the omega AB multiplied by the length of the link, which is 1. That's going downward, so it's going to be considered to be a negative value. Okay, I don't think that's something hard to be done or something you can write it down as relative velocity equation. So the velocity at the A is going to be equal to 0. Okay, is going to be equal to 0. And from there, we can write down that the 0, which is velocity at the A, is going to be equal to the velocity of the B as a vector, which is going to be only for the y direction, so it's going to be j plus the omega k multiplied by cross section of 1 I. Sorry, that's 1 I. So we will come to the equation that 0 is going to be equal to VBJ VBJ and plus the k times the I is going to be j, so we're going to have the omega j. And we will come to the conclusion that the VB is going to be equal to negative omega AB. So I just take it to the long way to get the same results. Now, after we know what the velocity B is, we can take it to the other link and write down another relative velocity equation for that link. Now, we know the VB, which is going to be simply omega minus omega AB j, because it's going to go downward in the y direction. This one is negative 4j, and the omega, this omega BC, not AB, BC, okay, is going to be multiplied by the two components of the link BC, which is going to be the x and the y. Now, to go to the point B, we need to move positively to a distance of 1.5 times cosine of 30, then positively to the distance of 1.5 multiplied by the sine of the 30. Okay, that's have the I, this one have the J, and we can write it down once again as a relative velocity equation. So this will be my new relative velocity equation. Remember that this should be vectors here, okay? And now I can simply substitute the value I have. So for the RCB, it's going to be 1.5 cosine 30 I plus 1.5 sine 30 J. Now I'm going to substitute that in the equation of the VC, knowing that the VC is minus 4J, okay? And the VB is equal to minus omega AB J, and the omega BC K multiplied by 1.5 cosine of 30I plus 1.5 sine of 30J should be also calculated. So that's what we're going to get. Once again, here, the K times the I is going to be equal to J. So we're going to have negative 1.299 omega BC J. And the K times the J is going to be negative I times negative omega BC. So we're going to have plus 0.75 omega BC I. So the equation now can be written in this way. And now we are going to consider the i's with the i's and the j with the j. So what we can see here that we have 1, 2, and 3 j's, while we only have one of the I. So to solve that, we are going to rearrange the equations, substitute the i's with the 0 on the other side. So we have 0I here. So the 0.75 omega BCI is equal to 0I, and we can say that the omega BC is equal to 0. While the other side, we're going to have the minus 4J is equal to the omega minus omega AB plus 1.299 omega BC J. And thus, we're going to solve now the problem. We have the omega AB and the omega BC. This one is found to be 0, so this part will go to 0, and we'll say that the omega AB is equal to 4 radian per second, and done. That's the answer we have for this question. Okay, so the only trick we have is that we just start to use the simplest relative velocity equation to find a relation between the velocity at the B and the omega AB, remembering that at this situation, we have the link AB is horizontal. That means the velocity AB is going to be a vertical direction. And then we take it to the link BC to find the unknown value of the omega BC and the value for the omega AB. And the question has been solved.